Hello everyone. We are here today to demonstrate a short video explaining Savvius network performance monitoring and diagnostic solution based upon Ixia's CloudLens infrastructure. My name is Nadeem Zahid. I'm Senior Director of Business Development at Savvius. With me is Greg Copland from Ixia, who is Director of Systems Engineering. And I also have Jay Botello, who is Senior Director of Engineering at Savvius. And Greg and Jay are going to actually drive this demonstration and show you how Savvius and Ixia solution works. Let me first explain a little bit at very high level some of the components of the solution. As you can see here, Ixia CloudLens has a central SaaS application called CloudLens, which talks to client hosts or client servers through a Docker container and can have visibility into client applications and can relay the application data or packet data to Savvius virtual appliance or Omni appliance running also in a virtualized environment over an encrypted tunnel. And Omni Peak, which is our analysis software, then can be connected through a single pane of glass mechanism on physical on-premises solution on the left, as well as to the Omni appliance in the cloud, and provide visibility into the packet data-based analysis. Analytics that we provide include, for example, top application protocols, network utilization, KPIs, dependency mapping, application latency, and multi-segment analysis. And Jay is going to demonstrate later on some of the real-time utilization, real-time analytics during this demo. Having said that, let me hand off to Greg, who is going to walk us through the Ixia Lens setup process to begin with.
Thank you very much, Nadeem. Before we begin, let me just show you one slide of how the CloudLens architecture fits together. So there are two components. One is the CloudLens sensor that installs on the instances that you wish to monitor, as well as the tools. And then the second is the management layer that receives metadata about those instances and can then take care of setting up tunnels between the monitored instances, creating filters, and forwarding that traffic to the monitoring tool, such as Savvius OmniPeak. So there are two pieces to getting this going. One is to get the CloudLens public sensor, which is delivered as a Docker container, onto the instances that you wish to monitor. So I'll demonstrate that first. Once I do that, the sensor will register up to the CloudLens management layer, which takes care of it from there. So let me shift gears and show you the first part. So here, for example, I am in my Amazon Web Services console. I have various instances that I might wish to capture monitoring traffic for. So for example, right now I'm highlighting a particular instance in Amazon. And when I register this up to CloudLens, it will know all this information about the instance, but it can also know about some additional tags which I add. So for example, I can give it my own tags, such as a name, to allow for more easy identification of what I want to monitor. For example, I've added a tag here called Client2 CentOS, or I can add owners or groupings of other things that I want to manage. Then to load the CloudLens sensor, the straightforward Docker run command, which I'll show here. I've saved it, and just to give you some background, what it's doing here is it's pulling our CloudLens sensor from the Docker Hub, registering it up to the CloudLens management layer, and it is joining it to a project, which identifies entities that a particular user wants to monitor. So to join this to the SaaS, I simply run this command, and in a moment, when we switch over to the CloudLens management interface, you're going to see this instance show up. So with that, let me stop sharing, and we'll switch over to the CloudLens management layer. What I'm showing you now is the CloudLens management interface. And You'll notice that there are already some instances in here being monitored, but if I go into this search criteria, I should now see the additional instance that I just added, client 2 CentOS 7. That is because our Docker sensor for CloudLens registered up to the SAS, and now can then create a monitoring group for it. So I could have put this in the same monitoring group as the original one, but we'll give it a different monitoring group for the purposes of the demo. So here is the second group. And just like the first group, I can now make a connection from it to my monitoring instance. And traffic can pass from one side to the other. Optionally, I can also set filters. So you see the first instance has a good amount of traffic going, 10 megabits per second, between the monitor side and the tool side. I could optionally set filters to choose which type of traffic I want to send for monitoring, for example, using common Berkeley packet filter syntax. If I want to send everything for analysis, I just leave the filter as IP. And the beauty of this is that the filters are set at the source, so they're set before they're ever sent out onto the cloud, thus saving bandwidth. Now you'll notice here that the traffic is being sent from the first group to the OmniPliance tool. It's not yet being sent from the second one, but as soon as traffic is being sent, it would also go over to the OmniPliance, and we would then see that this line will get larger to indicate the additional traffic. Notice, by the way, the project key that was used when we registered the sensor up to the CloudLens project. If we wanted to register additional instances up to the CloudLens, we don't have to go through the manual process of the Docker run command. We can simply include that in the startup data for the instance. This is something that's configurable in Amazon or with other cloud orchestration to run automatically. So with that, let me turn it over to Jay to show you the data showing up in the OmniPliance tool that's been captured from the client side in Amazon and sent over to OmniPliance for analysis.
Perfect. So thanks, Greg. So taking off from where you just were, we're right back here with the overall GUI. And just to refresh before we go ahead and actually show the connection into our tool, I just wanted to do a quick refresh of kind of, where we are. So what we've seen so far is, Greg was able to get those client hosts going, right? And that traffic's already funneling up back through Ixia CloudLens and now already funneling back down through to our solution, which is called OmniPliance. So all of this still located in the Amazon Web Service. So as you saw here, right, we have both client tool and client group 2 both feeding traffic into OmniPliance, and that's represented here up through CloudLens and back to OmniPliance. So this instance of OmniPliance will actually have both of those tools feeding into it. It'll aggregate that data into a single session, and then we will see all of that data at the same time. So for us, the way we look at that data is we look at it with a software application called OmniPeak. So our OmniPeak is our console into OmniPliance. So although we're looking at what I'm circling here with the mouse, this OmniPliance, we're actually looking at it through another piece of software. And that's this software right here. This is our OmniPeak software. And what OmniPeak does is, again, it's a console into that OmniPliance, and that OmniPliance is capturing all of the packet data between the client instances that Greg set up, and their communication. So, it's basically a virtual tap for each of those clients, and we're tapping that data back through CloudLens and then back into our OmniPliance, and now visualizing it in OmniPeak. So you might see some repetition of this data. It's because it is just test data, and we can see back to where there was data. The great thing about OmniPeak is this tremendous amount of rich data here. I'm just going to pause this for a minute. You can see just on this screen, we're looking at an overall graph of utilization here. You can, if you remember back at one point, the CloudLens application was reporting about a 10 megabit per second data feed, and you see that's about where we were if we drew an average, a little higher, a little lower, but we are at about 10 megabits per second. That's what we're seeing here. If we don't want to see utilization, there's many of the things that we can see and analyze there, including things like response times, latency, etc. To the right of that is ongoing analysis, which is just is going on as the packets are being captured, and we're looking for all different types of network events from layer 2 to layer 7. You can see we've seen a lot of non-responsive client data, some TCP retransmissions and connection issues, and then going down to just a few HTTP server errors. So this shows you exactly where the problems are happening on the network very, very quickly. And then if you want to see where and time, we could simply click on those, and you see it'll highlight where those are happening. Since there's so many, there's a lot of them, maybe it's easier to do the HTTP server issues, and we see that there was a server issue here and a server issue here. And that's great, because then we can also just come in and we zoom in on that period of time where that error happened. And then it reduces and changes all of the data to reflect just that period of time, so we can see what was going on at that time. So very, very straightforward in terms of the visibility here. We're also showing things like top protocols and top nodes. But there's much more to the things that we're able to see. Odds are the reason why you'd even be doing this in Amazon with a service is because you're running some sort of application of your own up there, and you want to see the connections between those applications. Maybe it's maybe it's Citrix, for example. So we can go into Citrix, and by coming into this view that we're in now, which is our expert view, meaning we're analyzing in real time all of the flows in and out of all of our applications. So in this case, we highlighted on Citrix, we see all of the servers, and again, mock data. We can go down another layer, see all of the clients, go a layer deeper even, and see what ports are being used there, and then by highlighting things like that area and coming into our details, we can see details about that flow or any flow that we click on. Including things like, best, worst, average response times, client to server, and server to client data rates, our overall sizes, our TCP window sizes, the routing hops. So we get a tremendous amount of data, most of it being the response time data, but all that all for each and every individual flow. If we want to treat it again from a problem perspective, we can go back to our event summary. These are the same experts we were looking at on the last graph. Maybe we want to see where the, let me see, let's find where the stuck window was reported. So we can click on any one of them. I clicked at the bottom here on this TCP stuck window, and you'll see that it highlighted a number of rows here for me automatically. This tells me that in these particular flows, we've had a TCP stuck window, and when I highlight it, you can see we've had that and a whole lot more in these flows, indicating that these are probably problem flows, in terms of HTTP that we want to go drill in more on. A few other views quickly as we go through this. Nadeem mentioned earlier the ability to do some flow mapping, and that's what we're able to do in our peer map, where we see the interaction for each and all of the flows on the network. It can look a little busy, but the nice thing is we can come in and we can clear all of those and look maybe for specific things. Maybe we want to look for, was there FTP? It says there was some FTP control somewhere. Who was doing that? Well, we come in and we very quickly isolate two flows that were doing FTP. Maybe that's even against our policies. Now we've already seen exactly what might be going on there. Probably not in the cloud, but a good example of how we can see that kind of stuff. In addition, if you were doing any voice or there was any real-time protocol information up in the cloud, we do full VoIP analysis as well. So you can see we have picked up at least some RTP traffic. And again, this is because this is traffic that we're generating between that client and that server. But if you had VoIP traffic that was flowing up through Amazon for some reason, you could see all of that as well. let me see, last not least, you can see things like the various applications that are in use, all ranked by in this case, by the number of bytes, but we can sort them in a number of different ways. You can see everything that's being used. You can see we're using Twitter and YouTube. Someone doing a file transfer for Apple Update, taking up a pretty significant amount of our bandwidth. So all of this is readily available to you. All of it now enabled and done in the cloud. The only part of this that is not running in the cloud is OmniPeak. I'm doing that sitting here, but the rest of this is accessing our appliance in the cloud that is then accessing all of the packet data that's been funneled through Ixia CloudLens. So it shows the excellent partnership that we're able to leverage between Ixia in terms of actually getting us this virtualized packet data and then our own appliance to do the detailed analysis of all of that packet level data to show you each and every kind of fault that you could imagine that's going on in that traffic between the virtual client and the virtual server. So with that, I'm going to turn it back over to Nadeem for a minute, just to summarize and close out for us.
Thank you very much, Jay. And so that was our quick demonstration of Ixia CloudLens and Savvius solution together. Hopefully you enjoyed it. Should you have any more questions, please feel free to visit savvius.com as well as ixia.com and find out more about CloudLens and Savvius solutions. Thank you very much.